Today's video will demonstrate how to design with ISA and HAZA. Hello, I'm James Helfrich. The two main types of class relations we have are inheritance and composition, but how do you tell which to use in a given circumstance? This video will demonstrate that process. Okay, let's start with what is ISA and HAZA. So ISA refers to inheritance, where a derived class is a specialization or a variation of the base class. And we can see things when we have the ISA in the problem definition. A savings account is a type of account. HAZA refers to composition, where the object is a member variable of another class. And we can usually tell when we have the word has a in a problem definition. A spaceship has a position. Now, we actually have four different options here. Number one is we can either use ISA or HAZA. Classes are unrelated, they're sibling classes, there's a bunch of other different scenarios. The next is HAZA, when only composition or aggregation will work. And this is common, for an example, when I have more than one instance of a class. When I have a collection, then HAZA really is my only option. The third is when ISA is the only possible relation. For an example, when you have polymorphism, you must use inheritance. You have no option. And the final option is when either composition or inheritance will work. Now, normally one of them is preferable, but in some cases, it's really not clear which it is. In that case, then prefer composition over inheritance. Let's take a look at an example here. So there are three types of contact information in an address book application: a phone number, an address, an email address, and a street address. So it might appear there are three types of addresses that are independent. I can say I have a phone number, an email, and a street address. However, they are all types of contacts. And since they're all types of contacts, then that sounds to me like ISA. So I'm going to take my my phone number, my email, my street address, but I'm going to relate them by ISA, which is going to be inheritance. Now, since we have a collection of addresses, however, we both have ISA and HAZA. In other words, the address book is going to have a collection of contacts, and this must be by composition. Another example, a chess program may have many types of pieces on the board: a king, a queen, a rook, etc. And each piece knows its symbol as well as how it can move. Now, at first glance, the various pieces seem to have nothing in common. I have a queen, a rook, a bishop, a king, a knight, and a pawn, making for 6 individual classes. However, we have two kind of categories of pieces: those that slide and those who do not. So we have the sliding pieces, the queen, the rook, the bishop, and the non-sliding pieces, the king, the knight, and the pawn. So now I can make a sliding versus non-sliding version. But all these are basic types of pieces, and so I have inheritance here as well. But notice I'm not done, because the board has a collection of pieces. How many? Well, 64 if you include spaces. In that case, I must use composition here. In a final example, a velocity consists of a direction, a speed, and a position. Now, direction and speed are scalars, but position is a class. So I use composition, or should I use inheritance? Now, notice that position is contained within velocity, but for my Venn diagram, but does that mean that composition or inheritance? It really could be either one here. And so on the left side here, I have composition. A velocity has a position. But on the right side, I have inheritance. We start with a position and we extend it with velocity. So really, both of these work. In fact, they work equally well. From an alignment perspective, however, the subject matter expert will probably say that a velocity has a position rather than a velocity is a special type of position. Therefore, we're going to prefer composition over inheritance. This is example 37.1, 37.2, and 37.3 in the ISA versus HAZA chapter of the software design textbook.